Hello, my name is Damaris Thrash. I'm an exercise science major at Lamar University, and my research is titled The Effects of Motivational Music on Post-Exercise Recovery. So, as can be gathered by the title of my research, the goal of this experiment was to study the physiological effects that take place in the body during the recovery period following exercise. The original idea, thought of by my mentor, Dr. Shannon, was to study how motivational music would affect the body during aerobic exercise, which is also known as exercise with a long duration, or it requires endurance training. However, our attention soon shifted to how music may impact the body following aerobic exercise, as there's been a very scarce amount of research conducted over how the body may be affected physiologically. So the period that takes place immediately after exercise is known as EPOC, or excessive post-exercise oxygen consumption. During this stage, the body returns to homeostasis, which means things such as heart rate, blood pressure, ventilatory rate, and oxygen consumption will all return to resting values. It's also the period the body clears any any lactate accumulated in the blood during the onset of exercise. To measure and analyze the changes that take place during EPOC, we decided to recruit a total of 20 participants, most of them being students at Lamar University. This was on account of attrition, or hoping to have enough data that a clear pattern was seen. With each participant we successfully recruited, we completed an initial evaluation, which included an informed consent and a PAR-Q, which is a IRB-approved screening tool. With this screening tool, we were able to make sure that all participants were healthy enough to exercise within our study. Participants meeting the criteria we had set then completed a treadmill exercise test to determine their aerobic fitness level, which is also known as VO2 peak. And throughout this test, heart rate, blood pressure, and blood lactate levels were all monitored. After participants finished the initial exercise test, we found 70% of their VO2 peak, and the participants performed 3 different exercise sessions. Each exercise session was performed 70% of their VO2 peak and had a 15-minute recovery period. So 3 different types of music were played during the recovery period of each session. These 3 different trials included listening to motivational music during exercise while listening to no music during recovery, listening to motivational music during exercise while listening to motivational music during recovery, and listening to motivational music during exercise while listening to calming music during recovery. Based on current literature regarding music during exercise, my original hypothesis was that listening to motivational music compared to listening to calming music or no music would extend the post-exercise recovery stage, and it would take longer for the body to return to resting values. In opposition, I also believed that calming music would make the body react in such a way that it would recover quicker, and the EPOC stage would have a shorter duration as compared to motivational music or no music at all. So previous literature considered motivational music to be songs that had a tempo of 120 to 140 beats per minute if it was expected to elicit any positive response during a high-intensity aerobic training exercise. Although motivational music is defined within previous literature, there is no definition of calming music in any of the literature we reviewed beforehand. So this is what a normal day in the lab looks like. First, we always gather all the materials we need, such as hoses, headgear, and the equipment to make mouthpieces, which is what I'm doing right now. We also take heart rate, blood pressure, and lactate, so we'll gather materials for those. We also need to perform maintenance on the metabolic cart each day before a participant comes in. So to do that, we change out the filters and make sure there are clean hoses, and afterwards is when we actually calibrate the cart. So to do that, we use a 3-liter calibration syringe and push a known volume of air into the analyzer. We also perform a gas calibration using an analysis of room air composition and a known concentration of gas from a gas calibration tank. By doing that, the metabolic cart should be accurately measuring the metabolic gas exchange variables that we'll be looking at. This is what it looks like when we have a participant performing. We're constantly monitoring their blood pressure, blood lactate levels, and their heart rate. In this video, you can tell this particular participant is running for their VO2 peak because the speed and incline are constantly increasing. When we have them perform at 70% of their VO2 peak, the speed and grade should remain fairly constant. The participant is now performing at 70% of their VO2 peak for 20 minutes. We will be checking their vitals and blood lactate during the 10th and 20th minute. And then we will check immediately after exercise and during the 17th and 15th minute of recovery as well. And of course, we always disinfect and sanitize everything after each participant. The goal for each 20-minute exercise session was to have the participants exercise at 70% of their VO2 max, or their maximal aerobic capacity. In this table, you can see the percent VO2 max was similar between treatment groups, and we were able to hold the exercise intensity steady in order to ensure that any results were not due to different exercise intensities between trials. Our findings showed no significant differences between the epoch or recovery stage between treatments for the variables measured. The data in this table depicts the 15-minute epoch period. IPE stands for immediately post-exercise. Participants had stopped exercising and stood still on the treadmill for the IPE measurements. Participants then sat quietly for the remainder of the 15-minute epoch period, where measurements were taken at 7 and 15 minutes post-exercise. Data represented in this table are heart rate, systolic and diastolic blood pressure, and blood lactate. Data represented in this table are absolute and relative VO2, ventilation, and respiratory rate during each measurement period of the epoch. Respiratory exchange ratio, which is the ratio of expired volume, of CO2 to O2, is reported in this table. No significant differences were found between treatment conditions. This conflicts with our hypothesis that calm music or no music would allow participants to recover quicker during the epoch stage. At this time, a total of 10 participants have finished the experiment. Our findings have already been presented at the Lamar OUR Expo in the spring of 2022. However, we also hope to present this project at the Texas ACSM Awards in the spring of 2023. Following this, we plan to produce a manuscript once all 20 of our participants have completed the study. However, only 10 have completed it thus far. And looking at that data, we see that no music seems to affect the recovery process that follows exercise. Thank you.